Welcome back to the deep dive. Okay, so picture this. You walk into a conference room, laptop in hand, plug it in, and nothing. Just that awful blank screen. We've all been there, right? That presentation room panic.
Okay.
Well, today's deep dive is for you. We're going to dissect a single, pretty powerful piece of AV gear designed to make all that chaos just disappear. It's the Key Digital KDU PS52U presentation switcher.
Right, and our mission really is to unpack this device. We want to understand how it manages to solve, like, three big problems at once.
Okay.
Handling basically every modern input you can think of, making sure that 4K signal gets where it needs to go reliably, even over long distances, and simplifying how you control all the peripherals, all packed into one box.
And yeah, we should probably clarify right up front, this is sold as a kit, isn't it?
That's right.
It's the main KD UPS52U switch unit, but it comes paired with the KD X100 MRX receiver unit. You actually need that receiver at the other end to get the full distance and the power capabilities we're going to talk about.
Exactly. It's designed as an integrated system. Think of it as the central nervous system, the connectivity hub for these modern high-res meeting spaces.
Okay, let's start with that connectivity then. The U in the name, KDUPS52U, stands for universal. Now, that's a pretty bold claim, especially with laptop ports changing all the time. What inputs are we actually talking about here? How does it earn that universal title?
Well, it really does cover the bases. You've got 5 different input paths. There are 2 standard HDMI inputs, which is good. Then there's 1 DisplayPort input, still very common.
Crucial. Yeah.
Crucial. And then 1 USB-C source input, which, as we know, is becoming the standard pretty fast.
Definitely.
And finally, there's an HDBaseT input as well. That's typically for maybe a remote wall plate transmitter or some other permanent source in the room. So yeah, that variety means people aren't scrambling for dongles, hopefully.
Right, no more dongle panic. And that USB-C, that's key because it's not just video, is it? It's video, data, often power too.
Precisely. It handles multiple streams.
Okay, so you've got all these inputs covered. That's one side of the equation. Once you pick a source, where does the signal actually go? What are the outputs?
You get 2 outputs, and they're mirrored. So same signal on both. One is a standard HDMI output, maybe for a local monitor right there at the rack or under the table. And the other is an HDBaseT output. That's the one designed for the long haul, sending the signal out to that receiver unit we mentioned, the KDX100 MRX.
So you could have a local confidence monitor and feed the main display across the room simultaneously?
Exactly. That duality gives you flexibility.
So I'm the person walking into the room. How do I actually choose which of those 5 inputs get sent out? Is it complicated? Do I need like a Crestron programmer on speed dial?
Hopefully not for just basic switching. There are options. You've got physical push buttons right on the unit itself.
That's simple now.
But for integrated rooms, it supports control over IP, standard RS-232, IR remote control, even trigger control. But honestly, for the everyday user, the real magic is the auto-sensing feature.
Ah, auto-sensing. That's the thing that stops the meeting grinding to a halt while someone fiddles.
Exactly that. You plug in a new laptop, it detects the signal, boom, it switches automatically to that new source.
Nice.
And just as important, maybe even more so, when someone unplugs their cable and walks off, it detects that disconnection and automatically switches away maybe to the next active source or default one.
Yeah.
It just eliminates that awkward dead air.
Yeah.
That, okay, whose turn is it
Yeah.
moment.
Yeah, that focus on just making it work seamlessly is huge. And you mentioned installation. It's a half-rack unit. Can mount pretty much anywhere.
Right, under a table, in a small rack. Comes with the mounting gears. Oh, and it's TAA compliant too, which matters for government or institutional installs.
Good point. Okay, so let's shift gears to performance because this is where it gets really interesting. 4K 18G. That 18 gigabits per second, what does that bandwidth actually buy you in terms of picture quality on the screen?
It buys you, well, basically perfect color. We're talking resolutions up to 4K, technically for the NI6 by 2160 at 60 hertz.
Yeah.
But the really critical spec within that is the color space, 4.4.4.
Okay, why is 4.4.4 so important? I hear that thrown around a lot. Isn't most video content compressed anyway?
It often is, yes. If you're just watching a movie, you might get away with 4.2.2 or even 4.2.0 color compression.
Yeah.
But think about a presentation room. You're looking at spreadsheets with fine lines.
Right, text.
Detailed graphs, CAD drawings, anything where sharp edges and distinct colors matter. That 4.4.4 means there's no compression on the color information. Every pixel gets its full color data, keeps text crisp, lines sharp. It's essential for any kind of detailed computer graphics.
So it avoids that slightly fuzzy look you sometimes get on text with lower bandwidth signals?
Exactly. It's uncompromised color.
And speaking of a compromise, what about security? In corporate settings, education, you need to handle protected content.
Absolutely. That's non-negotiable. This unit is fully licensed and compatible with HDCP 2.2. That's the latest standard for handling encrypted 4K content from sources like Blu-ray players or streaming boxes.
Okay.
Plus, it supports the advanced imaging standards too, like HDR10 and even Dolby Vision, so it's compatible with the best quality displays out there.
Right. But the big challenge with high bandwidth signals like 18 Gbps 4K is always distance, isn't it? HDMI cables themselves have limits. How does this system reliably push that full signal across, say, a large lecture hall or auditorium?
Yeah, that's precisely where that HDBaseT technology and the included receiver unit come into play. Using a single standard category cable, like Cat6 or Cat6A,
Uh-huh.
it can extend that full 4K UHD signal, the full 18 gigabits per second, up to 100 meters. It's 328 feet.
Wow, okay. 100 meters is significant.
It is. And if you're only running, say, 1080p, which needs less bandwidth, that distance extends even further, out to 150 meters, or about 492 feet.
Hang on, if you're running a cable 100 meters away to the receiver behind the display, doesn't that receiver need its own power? That usually means getting an electrician to install an outlet back there, which adds cost and hassle.
Ah, good point. But no, that's another HDBaseT benefit this unit uses, power over HDBaseT, or POH.
Okay, so like power over Ethernet, but for HDBaseT?
Exactly the same principle. The main KD UPS52U switcher unit actually sends power down that same category cable to the remote KDX100 MRX receiver.
Oh, that's clever.
Yeah, so you don't need a separate power brick, no dedicated wall outlet needed behind the display or projector at the far end. It really simplifies the wiring part of the installation, makes it cleaner and often cheaper.
That definitely lowers the install complexity. Now, with all this high-speed data flying down long cables and sources switching, stability is paramount. Signals can degrade, handshakes can fail. What's inside this box working to make sure the connection stays solid?
Key Digital has their own proprietary tech for this. They call it the full buffer system. You can think of it like a signal traffic controller and conditioner, all in one.
Okay.
It sits there managing the data stream. It performs, I think, 4 key things. First, TMDS reclocking and signal regeneration, basically cleaning up the timing of the digital signal.
Right.
Second, it manages the whole HTTP authentication process between source and display, ensuring that encryption handshake works smoothly. Third, it handles the EDIDE control handshake. We should talk more about that.
Yeah, EDIDE is always a headache.
Always. And fourth, it manages the hot plug detect voltage, which is how devices know something's been connected or disconnected. So it's basically managing all the critical points where a digital video connection might fail.
Okay, let's circle back to EDIDE then. That's the extended display identification data, right?
Right.
Where the display tells the source what resolutions it can handle.
Exactly. And it's notoriously finicky.
So why is having, as the specs say, 15 internal ED handshakes stored in this switcher valuable? Why not just copy the ED from the actual display connected?
Because, frankly, sometimes the display's ED lies, or it's slow, or it's incomplete. A projector might claim it can do a certain resolution, but maybe not reliably, or the handshake just takes too long, causing delays.
Ah, okay.
Having those 15 built-in ED profiles, including specific ones for 4K with HDR, allows the installer to basically force a known, good, stable handshake. They can tell the source device, look, send out this exact format, regardless of what the display is saying at that moment. It guarantees a faster, more reliable startup every single time. It's about engineering for reliability, not just hoping the display plays nice.
That makes a lot of sense. Proactive problem solving. And that's a really good transition, actually, because we've hit signal stability hard. Let's talk about the user experience beyond just getting video on screen. Modern meetings are about collaboration, right? Using the room's good camera, the good microphones. This is where the specs mention the soft codec enabling system. What does that mean in practice?
Right. This is really what makes the KD UPS52U feel like part of a modern collaboration setup. It has USB host and device ports, both on the main switcher unit and on that remote receiver.
Okay.
This effectively turns the whole system, the switcher and receiver pair, into a USB hub or a KVM switch, depending on how you configure it.
So if I walk in, plug my laptop into that USB-C port, I get my video signal going out, obviously. But what else happens with USB?
You also get connected to the room's USB peripherals. So that professional USB camera mounted in the room, or the ceiling microphones, maybe an audio DSP, even a shared keyboard, mouse, or a touchscreen display. They all become available to your laptop instantly through that single USB-C connection. Or if you connect it via HDMI DisplayPort plus a separate USB-B cable to the switcher.
So my laptop, running Zoom or Teams or whatever, suddenly sees the room's high-quality gear as if it were plugged directly into my machine.
Exactly. It bridges that gap. It makes the room's pro AV gear easily accessible to whatever soft codec software or conferencing application you're using on your own device.
Why is that integrated system better than, say, just having a separate, maybe cheaper USB switch on the table or relying on Bluetooth peripherals?
Performance, reliability, and control integration. This system is designed to handle the high bandwidth needed for things like professional 4K USB cameras. Key Digital even mentions native integration for their own KD-KM USB, allowing full camera control, pan, tilt, zoom, through the switcher's control interfaces.
Ah, so you can control the room camera from the main control system.
Right. And it ensures that the USB switching is reliable and follows the video source selection smoothly. It just makes the whole experience less clunky than juggling separate devices. It aims to make the room's equipment feel like a natural extension of your laptop.
Okay, that makes sense. Plug and play room peripherals. Now, speaking of control, another common headache is just controlling the display itself. Turning it on, off, adjusting volume, muting. That usually involves extra IR emitters or RS-232 wiring to the display, right?
Traditionally, yes. More cables, more programming complexity.
How does the switcher simplify that part?
It uses something called CEC Manager. CEC stands for Consumer Electronics Control. It's actually a feature built into the HDMI standard itself that most modern displays and projectors support.
Right, I've seen that on my TV remote sometimes.
Exactly. So the UPS52U can send basic commands, power on-off, volume up-down, mute toggle directly over the same HDMI cable or the HDBaseT link, which carries HDMI, that's already sending the video and audio.
Oh, that's very neat.
It means for basic display control, you often don't need any additional control wires run to the display at all. It simplifies the installation, reduces cable clutter, and cuts down on programming time for the installer. Big win.
Definitely sounds like it. Now, for bigger, more complex installations, corporate boardrooms, university campuses, they usually have a standardized control system, like Crestron or AMX. How does this device play in that sandbox?
It plays very nicely. It's designed for full integration. For quick setups for smaller rooms, they mentioned it's KD app ready. You can scan the network with their app. It finds the switcher and populates a pre-built control interface on your phone or tablet.
Okay, handy for simple control.
But for the serious integration, it has an open API. It's fully controllable via TCP/IP over the network or via traditional RS-232 serial commands.
So it speaks the language of the big control systems.
Exactly.
Yeah.
They explicitly list support for Compass Control Pro, which is Key Digital's own system, but also AMX, Crestron, CanX, RTI, Savant, URC, Leviton. Basically, all the major players are covered. This ensures it can slot into almost any existing enterprise control environment. That redundancy in control options is critical for institutions.
Makes sense. You need it to work with what's already there.
Hmm.
Okay, one last area before we wrap up. Audio, we've talked video, USB, control. What about handling the sound?
Audio is handled cleanly through de-embedding. At the main switcher unit, it can extract the audio signal from whichever video source is currently selected.
Okay.
And it gives you that audio on dedicated outputs. You get analog audio on balanced, unbalanced LR connectors, things Phoenix connectors or RCAs, and also digital audio via a PCM connector, like optical or coax.
So you can feed the room's separate sound system easily?
Precisely. Feed it directly into an amplifier or audio mixer. And importantly, it confirms support for passing through lossless, compressed digital audio formats. So things like Dolby True HD, Dolby Atmos, DTS HD Master Audio. If your source is sending that, it can pass it through or de-embed the core track, ensuring you don't lose audio quality going into a high-end sound system.
So no compromise on the sound either.
Right.
Okay, let's try and tie this all together then. What does this all mean for someone designing or using a presentation space? What's the big picture takeaway on the UPS52U?
I think the big picture is integration and simplification.
Yeah.
It's taking this potentially messy world of different video formats, long distances, USB peripherals, display control, audio extraction, and standardizing it. It puts it all into one reliable box.
Right. It's aiming to be that central hub that just handles everything.
Exactly. It minimizes the installation complexity, less wiring, integrated power, built-in control features, while maximizing the reliability for the installer and, maybe more importantly, providing that simple plug-and-play experience for the end user walking into the room. That's the real goal, isn't it? Making the tech disappear.
Making the tech disappear so the meeting can happen.
Yeah. Now, something we noticed looking through the specs, it provides bidirectional RS-232 control, not just to the switcher, but potentially through it, between the TX, if used, and RX units. And it maintains the strong emphasis on legacy control, like RS-232, alongside the modern HDBaseT signal path.
Right, it doesn't completely abandon those older, very reliable point-to-point control methods. Which brings us to a final provocative thought for you, our listener, to chew on. In a world that seems to be rapidly shifting towards purely networked AV over IP solutions, where everything just runs over the standard network, what's the strategic advantage, do you think, of this device deliberately including and managing dedicated legacy control paths like RS-232 and using HDBaseT, which guarantees a dedicated signal path with fixed bandwidth separate from the main data network?
Especially for those large institutional users, think big corporations, government, military, where maybe absolute guaranteed reliability and predictable performance sometimes trump the flexibility of a pure IP network. Is there still a strong case for these dedicated, non-network congested signal paths in critical environments?
Something to think about. What value does that guaranteed pipe still hold? Explore that, and we'll catch you on the next deep dive. Thanks for joining us.